Hi, this video summarizes periodicity of ionization energy and atomic radii across a period. Now, if you look at the two periods that are denoted here, if you look at the electronic configuration, if we stick to the second period that's displayed in pink here, if you look carefully, the electrons are added as you go along the period. They come to the same shell. So if you observe in the second period here, the electron goes to the second shell. So as you go across a period, the number of electrons are increasing, but they are entering the same shell. Same way in period 3, if you look at sodium, the electron is going in 3s, whereas in argon still we are continuing with the third shell itself. So as you go across a period, the number of electrons are increasing, but they're entering the same shell. And that's depicted again by this picture. As you go across, if the number of electrons are increasing, the number of protons would also increase. Therefore, the number of, or the amount of nuclear charge has also increased across a period. But the distance between the nucleus and the outermost shells remains the same, because as we discussed in the first slide, the electron is entering the same shell, so obviously the distance stays the same even though the effective nuclear charge has increased. If the distance remains the same, that indicates the shielding between the nucleus and the outermost shell is also the same. This means that the increased nuclear charge will pull the electron in the outermost shell closer to the nuclei, and therefore the outermost shell electron is pulled closer to the nucleus, and hence the size would decrease. Now, if you look at the trend in the ionization energy across a period, you will see the trend. If you go across the second period from lithium to neon, the general trend is ionization energy is increasing because the atomic radii has decreased, and therefore the amount of energy needed to remove the electron from the last shell would be higher. Therefore, the ionization energy would increase across a period. Now the question is, if you look carefully, there are two peaks here. One is peak for group 2 and another for group 5. So that was your period 2. And if you look again in period 3, the same trend is seen. The ionization energy is increasing, but same as here, the group 2 and group 5 is showing an increase. Now if you think about their electronic configuration, something about half-filled and fully filled orbitals being very stable, you can work out the reason for this particular change. So in a nutshell, factors affecting ionization energy, whether you're answering your exam question about the trend down the group or across a period, you should definitely include these three factors. You should talk about the distance of the electron from the nucleus, the size of the nuclear charge, and the shielding effect by the full inner shells. Thank you.